this is the start of the class. Hopefully you've managed to attempt to now. So now let's give solutions to this. So I think these are important, solutions, as much as, you're not going to be asked this in isolation. So this is even more important to know how to do it, because when they ask you, they're going to ask you, or you're going to have to know how to do it within a complicated question, which makes it a bit hard. But anyway, we have x plus 1 cubed. If you want, you can write this as x plus 1 and then think about this, or maybe just write it like this, just all together. For me, I already kind of know the result of this, so I'll just write that down. I know the result of that. If you've done a lot of these, you should kind of know. But even if you don't know the result of that, even if you do not know the result of that, these are sort of like rainbow sums. You take this, you multiply with that, take that, multiply it with that, take this, multiply it with that, and you take that and multiply it with that. Right, so I would leave the x plus 1 like that, and I would have x squared plus 2x plus, 1. Okay, then I can further do the rainbow sums, we just remove these ones just to make things clear for the next round. I can take this, multiply it with that, and take that, same thing, multiply it with that, and take that and multiply it with that. I'll do the same thing on the second term, like that. I think I already know the result of the whole entire expression, but that just comes after doing a lot of these problems. But yeah, I would just follow the process with this one. So, yes. So it's x times x, so that would be x cubed. X times 2x, that would be plus 2x squared. X times 1, that would be plus x. 1 times x squared, that would be x squared. 1 times 2x, that would be plus 2x. 1 times 1, that would be just 1. Look for my like terms. This guy seems similar to that, and that guy seems similar to that. Similar, they are like terms, you can add them. X to the power 3 plus 3x squared plus 3x plus 1. Okay, are we happy? Is everyone happy?
Yes, sir.
Yes, sir.
Okay, so here we have p minus q minus x, q minus p. That I didn't write it like properly in terms of, saying p minus q. When it's in bracket, it actually does make a difference, q minus p. So at this point, you can realize something, and that is you can take out a common factor, right? So wait, hang on. Okay, you would ideally want to take a common factor, but these guys don't look the same. You have p minus q and q minus p. So maybe just a side note. Start off with the problem that we are faced with. P minus q is not equal to q minus p. And the same way that 2 minus 4 is not equal to 4 minus 2. Yes. So we would have to do something here to make sure that this conforms, or, it's what we want. What I normally do, I leave the first bracket. I don't have to, but I just leave it like that and be like, you know what? I want my second bracket to look at like the first one. So I will swap p and x, p and q, swap p and q. After I swap p and q, the x is there, I have to change this sign, right? Swap p and q, change that sign, right? Not sure if that makes sense. Swap p and q, change that sign. We actually call this some nice term. We call it the switch around. So you switch around the terms and you change the sign. So we call it to switch around. Probably you switch the terms and you switch you switch the terms and you also switch the sign, if that made sense. I'm getting a lot of messages here. I'm not sure if it's you guys asking me something. Okay. So this would be P minus Q, and then I will be left with 1 plus X. Yes. Okay, are we happy? This was just do now.
Yes.
So
Yes, sir.
it wouldn't have been difficult, but maybe to some of the students that are not here, this part was one part that I just had to do from last week's class, you know. So if you think about what we had done until then, you will see we had done this problem number 5, which was nice and sweet, and we were about to do this problem and we had to leave class. You know, if I were to do this problem, it's the same switch around kind of idea. I would leave the first bracket, as I've said, and I will come rearrange this the way I would like it to be. Then I would change the sign, you know, then I'm done. You know, again, at this point, I can take a common factor. It's 2m minus n, and I'm left with k plus p. And that's like equals, it's equals. Yes, we are happy. Okay, that's from last week's. Okay, today, what are we looking at? Today, we are today we are factorizing a trinomial. A trinomial. Okay, so I always complain about how this is called. It's called the trinomial. Trinomial is just an expression with 3 terms. I don't know why this method is called a trinomial. Okay, anyway, I call it a trinomial. Do I have another name that I could suggest? I don't know yet. But yeah, this is called a trinomial. And I'll give about 3 types of factorizing a trinomial. And that covers trinomial. The way I do this trinomial, it's a bit efficient in the sense that when you do it, it's guaranteed you will get the correct answer. So it's efficient in that sense. Let's take one example, the first one. You have x squared minus x minus 6. This is a trinomial, right? There are 3 terms, they are all not like terms, so it's definitely a trinomial. How do we do it? We look at this value over here, you know, maybe ignore the sign if you want. I think I would ignore the sign. So just look at 6. Then you look at 6, and then you look at factors of 6. You then have 6 and 1, you have 3 and 2, you know, and look at these, the pairs of these factors, and look at which ones can you add or subtract such that you get minus x. Now, if this is minus 3 and this is, if this is minus 3 and this is plus 2, that looks fine to me. That gives us minus x. Now, however, when you go right then there, you say x squared minus 3x plus 2x minus 6. When you look at your expression, you have not changed anything. That makes absolute sense to me. So you would then have, you then group, you know, you group the first ones. Part of what I normally stress about this part, just for your convenience, just make sure that the signs in the brackets are the same. Right. After you've done that, you can factorize the first bracket and factorize the second one. So when you factorize with the common factor, because we've done common factor now, so we know how to take a common factor. So when you factorize that one, you will have x minus 3 plus, if you factorize the second one, take out 2, you'll be left with x minus 3. Guys, what's happening here is purely you taking a common factor. right? So there's no, and which is something that we've done so far. Okay, now suddenly you see that the stuff that are left as a common factor, it's actually x minus 3 left as a common factor. So x minus 3, and then what is left is then x plus 2. This is sort of like the first type, this is sort of like the first type. It's simple. The coefficient of x squared is 1. And you don't necessarily have a common factor, right? And when I say common factor in the actual expression here, there is no common factor, right? Maybe let me write this properly. The first type, and number 1, the coefficient of x squared is 1, and number 2, you have no common factor. What I'm saying right now, this point might be a bit vague because, we did at the end have common factor. What am I talking about? In the actual expression, you can't look at the expression and be like, let me take a common factor of 2, or let me take a common factor of 3, you can't do that. Okay, anyway, let's do a second example. Right, maybe let me talk about the second example before I do it. I consider the second example type 2, right? The coefficient of x squared is not 1. Is not 1. And also, you can take out a common factor. You can take out a common factor. However, when you've taken out a common factor, this problem becomes, it becomes type 1. Right, not sure if it makes sense, but well, we'll see. I'm very tempted to just, actually just take this example over here, times it by 2, and then, have it as a new problem. But perhaps that sounds a bit lazy. Let me give you a fresh one. 2x squared plus 2x minus 12. Similar though. Anyway, here we do have a common factor. When you look at this expression, especially knowing that every time when you factorize, you must take a common factor, you do realize that you can take out a common factor of 2, and you are left with 2x plus x minus 6. Now, the factors that you take, because now what you're factorizing is this thing inside here. So the factors that you will take are the factors of 6. So it's still 6 and 1, and 2 and 3. And you look at the combinations that would give you a positive 3. Those combinations, it's when this 3 is positive and this 2 is negative. So this would look like 2 brackets x squared minus 2. I want to do that. It's minus 2x plus 3x minus 6, close the brackets. That would give you, if you look at the first ones, you can sort of like group x squared minus 2x like that. And then group this business over here, which is 3x minus 6 rather, my apologies. And then you have it like that. Now, as I'm continuing, just note that this problem now is a classic example of type 1. As soon as I took out the common factor, this problem was then just, the same as type 1. Okay, you're still going to take out a common factor in that bracket. So you would have x minus 2 left there. Take out the common factor in the second one, you will be left with x minus 2 as well. So inside your bracket, inside your bracket, you do realize that you have a common factor there of x minus 2. If you look closely, if you take this x minus 2, you'll be left with x here. And on this side, you'll be left with what? With the 3. Okay, now you have too many sets of brackets. Perhaps you don't need the very outer brackets. So you can multiply the 2 inside with this 1 that is here. And then you'll have 2x minus 2x plus 3. Okay, and you are done. Right, and you are done. Okay. I mean, let me just say, now we're gonna go to type 3. You will realize you could have chose not to factorize this, which is bad, but you would have to find factors of 2 times 12, which is factors of quite a big number, and you just have to ensure that they make 2x. You could do it that, but no, I don't advise it. Let's look at type 3. I'll probably explain why I would, So type 3 has, so there is no common factor on the actual expression, and the coefficient of x squared is not 1. We probably just say, then let's say a is not 1. So it's not type 1 and it's not type 2, right? Let's look at it. So let me see what I can give you for that one. Something, okay, let's take 15x squared minus 2x minus 1. Now for this one, where the coefficient of x squared is not 1, you take that coefficient of x squared and you take this number, that value there. You multiply them, 15 times 1. You don't care about the signs. I actually don't care about the signs. You'll deal with the signs later on. And then that's 15. And you're just going to be looking at factors of 15. And you're looking at which of these pairs. This is where you take care of signs. When you start assigning signs into these numbers, say which one should be positive or which one should be negative. For me to get negative 2x, this must be negative, this must be positive. So now with that, you then can say this is 15x squared minus 5x plus 3x minus 1. If you look closely there, you can group this nicely. Plus 3x minus 1, nicely. And then you can take out a common factor of 5 and you will be left with 3x minus 1 plus 3x minus 1. So nicely, we have 3x minus 1 and 3x minus 1. Take it out as a common factor. Why do I feel like there's some thing that happened here that's not ideal? Anyone wants to help me here? What's going on here? Something unusual? Is everything fine? Yes, it's not fine. This is supposed to be 5x coming out. I'm looking at it and I'm like, what's going to be left in that bracket is just going to be a number. And I'm just like, what's going on? Of course, 3x minus 1 is our common factor. And then we'll be left with 5x plus 1. Okay, are we happy, guys? Okay, I wanna get a sense of how everyone's feeling. Everyone is just quiet and I'm talking. How's everyone feeling?
So we understand. Hope I understand.
Okay. Okay, let me move on then. I'm left with 5 minutes, but I'll try to do difference of cubes and sum of cubes. They are quiet.
I don't.
Sorry?
I don't.
You don't understand?
Nope.
And okay, who doesn't understand again, just to get the name?
Abulele.
Oh, okay. Let's talk about it. Which part don't you understand? Do you understand the first one?
Yeah. Only the last question that you did.
Oh, okay. So basically, with the last one, just the type, just, you know, like overall, when you realize that you cannot take a common factor and the coefficient of x squared is not 1, which means that there's no way that you can make it 1, meaning that it doesn't fall into any of this type 1 or type 2 or type 1, doesn't, right? So we're like, okay, what do? We multiply that coefficient with this value that would be here, right? We refer to it as a C value, but yeah, we multiply them and then we get that number. After getting that number, we find the factors and then we assign them signs such that we get this number over here if we add them. Then we pick them. After picking them, we put them there and they indeed give us that -2. From there, we can group them. You know, it's normally easy to group, but sometimes it does get involved where you have to do things like, like what again? Like switch around and all those things. But yeah, this one is quite very straightforward, in the sense that you can group them. After grouping them, you take out 5x as a common factor. You are left with 3x minus 1. And then here, this was just 3x minus 1 from the start. If you take this out as a common factor, it would sit there, and what you will be left, it's going to be 5x plus 1. Is that doing some justice?
Yes, sir.
Okay, cool. If you want a lot of this practice, I am willing to give you some tutorial on it, and then you can just work through it. Okay, I don't want to rush this class, so I'm left with 2 minutes. If anyone doesn't understand anything, again, I'm willing to go over this again, but I have 2 minutes. So I'm not gonna do the difference of cubes and sum of cubes. I'll do it tomorrow. And then tomorrow it will be end of factorization, and I will be making a start on, what is this called again? Equations. Are we happy? Any questions? Maybe,
No, sir.
maybe let me show you for the last minute that's left. Let me show you something. Maybe say number 4. Maybe, okay, maybe I'm not gonna give it. Can I give this as a homework? If you're joining the class tomorrow, please go and attempt this. This is your do now for tomorrow. Right, go attempt this and see. And then, yeah, that's gonna be our do now for tomorrow. Actually, let me write it as such. Let me see. That's the do now for tomorrow. Okay, that's it from me. If you're attending the other class, I will start it at 6 exactly.
So will it have a different link or is it the same link?
It should be the same link. It's the same link.
Okay, sir.
Sure.
See you.
But can't we wait?
Sorry?
Can't we just wait?
You want to wait here? I'm doing calculus in the other class. Do you want to join?
Is it something I've done already? Or can you, we continue with the sums that you gave
Probably
today?
what we did today.
Okay.
If you want, you can join. You are welcome.
Okay.
Okay. This
Okay,
this
so
class is okay. Sharp.
Sir,
Yes.
I have a question in the tutorial of calculus number 7. Oh, I'm struggling there.
Okay, I'll get back to you.
Okay, so.